Today we are going to start our ACE Physics 20 with 9702 as a complete course revision in the form of crash course 2025 October, November over there. If I will talk about the complete syllabus according to examination point of view, then I will suggest here that you should try to focus on the paper when you are solving it. That will be much more supportive for your final exams over there, and try to uh, connect it properly to the precision. Try to read the question carefully, and the paper pattern, if you are done with 2 or 3 years past papers over there, you will be much supportive according to your exam. And if I say here that you should try to focus my guidelines of complete revision of the syllabus over there, then also check the paper solutions which I have attached in my YouTube videos in the and also I have given you the lecture form notes over there. Then it will be much easy for you. Let's start our physics. First of all, in the start, I will say that the first one which I will go with is the first section of our questions according to the MCQs, which is related to estimations, less reasonable estimations like that. Reasonable estimations should be taken into account. And when I go for reasonable estimation, then I will have to take number of apples in 1 kg of bag like that. I am giving some examples over here, which you should try to memorize. That can be many in numbers, but I will try to as I have extracted all of these from the last 20 years papers over there. So let's start with it. Like first of all, I'm saying number of apples in 1 kg. If I give the estimation for this one, the answer will be 4.6 apples over there. If I go with diameter of nucleus of an atom, diameter of nucleus of an atom, then I will say that it should be approximately equal to 1.75 multiplied 10 raised to power minus 15. And if I go for diameter of proton, then I will say here that it should be being taken as 1 multiplied 10 raised to power minus 15 meters over there. After that, if I go for diameter of neutron, there, then I will say that its value will approximately equal to 2.2 multiplied 10 raised to power minus 15 meter over there. If I go more about it, diameter of electron I will say less than 10 raised to power minus 15. Electron will be less than 10 raised to power minus 15. It means I should go for 10 raised to power minus 16 over there. Okay, let's move to the next section over there. Here I am taking more estimations. I have revised or I have checked, which I have tried to make this summary for estimation from the last 20 years papers, which he has given in different MCQ questions over there. Then after that, I will have to go for which I will say diameter of an atom over there, atom. Then I will say it should be being taken as 0.1 nanometer to 0.5 nanometer there. Then there is diameter of Earth, which we should know over there. Earth, if you know about the radius, that is 6,400 kilometer. I'm just doubling it, and I am writing is 12.8, like 6.4 and 12.8 multiplied 10 raised to power 6 meters over there can be written in this form. After that, I am saying diameter of moon over there can be taken as it will be smaller than Earth, but it should be diameter of moon 3.47 multiplied 10 raised to power 6 meters is the diameter of moon over there. I am trying to write all possible estimations which can be asked in your exams over there. After that, I am saying diameter of sun over there. Then we can take this is much larger as compared to Earth over there. Then I'm saying it is 7 multiplied 10 raised to power 8 meters over there. And then I will say here mass after diameter to be taken. I can also take the diameter of pencil over there. And if we take the diameter of pencil, then we can say it is approximately 0.5 to 1 centimeter can be taken as its estimation of approximation over there. And diameter of a hair on your head, then I am saying diameter of hair can be taken as 5 multiplied 10 raised to power minus 4 meters over there. After diameter, I am going to move towards the mass of different objects. Like I have taken the example of all the diameters. Now I will have to move towards the mass. First of all, I say mass of a protector, the device which is used in geometry. Mass of protector. Where we can say protector is 5 to 50 gram. 5 gram to 50 gram can be given as a range of mass of protector over there. After that, I can say here mass of adult human. Mass of adult human. If we take as an average or we can say estimation mass of, then it can be 50 to 100 kg. 50 to 100 kg. And here I used gram, even though this is not the SI base unit. If he is going towards take kilogram, then you will divide it by 1000 over there. After that, I am saying that mass of human, then mass of apple there. Then I can say it should be being taken as 200 to 500 gram. 500 gram there. And from here, if I go for mass of 30 cm plastic ruler over there, then mass of 30 cm plastic ruler over there, then I can say its mass can be taken as 10 to 100 gram. 10 to 100 gram over there can be taken. Just a second. I have a call over there. Okay, so such information which I was writing about here. Then I am taking mass of an orange. Mass of an orange. And that can be taken as 100 to 150 gram. 100 to 150 gram over there. These are the estimation values which I am trying to write for you. Okay, and for the mass is enough for this section. Then I'm saying that weight of 1000 cm cube of water. Weight of 1000 cm cube of water. If you want to take this, then I will say here it should be taken as 10 Newton over there. I will also say that density of air should be taken into account. Density of air, even though we can take it 1.29 like that, but 10 is power 3 over there. But exact value, if you are not knowing, then approximate value is 1.29 multiplied 10 raised to power 3 kg per meter cube. If you go with 1.3 or you can going with 1.2 10 raised to power 3, it's fine for you. After that, I am going towards density of water. We know that density of water is mostly 1000 kg per meter cube. Kg per meter cube is the unit of density over there. And I can also go over density of cooking oil. Density of cooking oil over there. Then I can take this density of cooking oil should be taken as 0.91 kg per meter cube. Per meter cube over there can be taken. Okay, let's move to the next section of density for the product of glycerine. Glycerine over there. Then I will say for cooking oil that I have written above 0.91, that is gram per cm cube. That is gram per cm cube over there. For glycerine as density, then I am writing here density of glycerine will be taken as 1.26 gram per cm cube over there. After that, I am going towards now volume of different objects. Volume of like first of all, I'm taking volume of human head. Human head over there. Then I am saying that volume of human head can be taken from 2 multiplied 10 raised to power 3 to 9 multiplied 10 raised to power 3 cm cube is the volume of head of a human over there. After that, I can take the volume of a nucleus. Volume of a nucleus of an atom. Nucleus of an atom is going to be taken again in the form of cm meter cube. If I take, then let's suppose 2.8 multiplied 10 raised to power minus 45 meter cube. 45 meter cube over there in meters. I have taken, you can take in centimeter cube over there. Then this value should be decreased by -6, and it should be -39 like that. Okay, and then I can take volume of after volume of nucleus and volume of cup of tea. Volume of cup of tea over there, then our cup of coffee over there. Then I can say it is approximately being taken to 1,000 to 3,000 cm cube over there. I can also write about the volume of, we will say, small bean. Small bean. All of these values, I'm again telling you, I have taken from the all past papers of 20 years over there. So you should little bit try to memorize or just go through for 2 to 3 times. Then it will be much easy for you to handle it. 0.5 cm cube over there for small bean. After that, pressure of 10-meter depth of water. Pressure of 10-meter depth of water over there. Then we can say if we are taking depth of water, then it should be taken as 10 raised to power 5 Pascal over there. Okay, and then after taking single part of, I am saying here, pressure over there. Now I'm moving towards the speed. Okay, let's go for speed. Then speed of sound in air. Speed of sound in air can be taken as approximately 300 to 340 meter per second. And we can also say speed of sound in water. Speed of sound in water over there can be taken as, I will say here, 1500 meter per second. And speed of sound in iron is approximately 5500. Not need to write over there. In chemistry, we use that value over there. So speed of jumbo jet. Speed of jumbo jet over there. This is the speed with which this jumbo jet is going to fly is 220 meter per second is the speed of the jumbo jet over there. We can also say what is the speed of car. Speed of car with which it can go at is 22 meter per second over there. You can convert it into kilometers by checking how much according to the speedometer is going to measure over there. Speed of human walking. Speed of human walking is being taken as 1.5 meter per second over there. And I will also say that even though these values are too much, just go 2 to 3 times through these values. Inshallah, you will be able to get approximate over there. Speed of snail over there. Speed of snail over there. And for that purpose, I will say speed of snail is approximately 0.001 meter per second over there. That is the speed of snail because he has to crawl over there. And speed of Earth around the sun is speed of Earth around sun is being taken as the value having 30,000 meter per second. 30,000 meter per second with which Earth is revolving around the sun over there. So these were little bit approximate values. We can also go for more approximations. If someone asks me, I will share the PDF of the file over there also. Okay, almost 10 more approximations are also included. Now I am moving towards the next sections of physical quantities that should be being taken into account for and physical quantities and units related to uncertainties over there. We know about, first of all, I will have to move absolute uncertainty. Absolute uncertainty. Remember that absolute uncertainty which I am taking when two quantities like x is being obtained by adding two quantities y and z, or I am getting here x which is obtained by subtracting two quantities over there. In both of these cases, you are going to add, yeah, like you are going to get absolute uncertainty just by adding their least counts over there. Then that will be the values which should be being taken as partial y, as a difference of y or least count of y, and it should be added with least count of the other quantity over there. And in this case, it should be staying the same over there, plus minus, and the change in y will be added into change in z when two quantities are added or even subtracted over there. On the other end, when we go for fractional uncertainty, after absolute uncertainty, I'm moving towards fractional uncertainty. Fractional uncertainty states that you will have to take that measurement being when measurement is multiplied or when measurement is divided, then fractional uncertainty should be being taken. Let's suppose I am taking here x is a quantity which is being obtained by multiplying y and z two quantities, or we are saying x is the quantity which is being obtained by dividing two quantities over there. Then in that case, remember that you will have to get the percentage uncertainties, fractional uncertainty, by getting the least count divided by total measurement will be being taken, which will equal to plus minus fractional uncertainty as least count divided by total quantity, and will be added with the other quantity uncertainty, fractional uncertainty over there. For example, I have taken partial z over z as a quantity over there. So remember that fractional uncertainty is going to talk like this. After that, there is a percentage uncertainty over there. And according to percentage uncertainty, I am just simply saying over here that when both of these quantities are having the same scenario, like they are being obtained by multiplying two quantities, or they are obtained by dividing the two quantities over there, then percentage uncertainties can be obtained just by multiplying by 100 to this quantity or to this quantity, means just multiply by 100 to fractional uncertainty, you will get percentage uncertainty over there. Functional uncertainty should be multiplying by 100, you will get percentage uncertainty over there. These were the basic rules of uncertainty to be taken into account for using different types of calculations over there. After that, I will have to move towards kinematics. Kinematics is basically the study of motion without discussing its cause over there. Then I will say in kinematics, we will have to take first of all the speed or velocity. Velocity is a vector quantity which should be being taken as a vector quantity, and speed is a scalar quantity. Just remember that which the formula you will use. I will say here that it is distance over time, distance or displacement, placement over time taken. And for this one, I will say that V is equal to D over T, where V is speed or velocity, D is distance or displacement, and T is the time taken over there. This is my first term over there. Second, and its unit is meter per second over there. And for second one, I take the acceleration over there. As we know, acceleration is rate of change of velocity. Acceleration is a rate of change of velocity, like final velocity minus initial velocity divided by time taken. It is also a vector quantity over there, and its unit is meter per second square over there. And here I have again to tell you, this is V is final velocity, U is initial velocity, T is time taken. It is a vector quantity. Acceleration can be positive, can be negative, like gravitational acceleration. When the ball is going upward, then it will be having value as negative. When ball is going downward, then it will have positive value as to be shown in the form of acceleration over there. After that, I will have to move towards first equation of motion, which is a derived form of this acceleration formula. Then I am saying first equation of motion. When you are not provided with the distance in the numerical problems, then you use V is equal to U plus AT, where V is final velocity, U is initial, A is uniform acceleration, and T is time taken over there. And for second equation of motion, at number 4, I am saying for second equation of motion, when we are provided not with the final velocity as like in this expression, then we use the formula S is equal to ut plus half at square, and the unknown variable present from these of them, we will use this formula where S is the distance traveled, U is initial velocity, T is time taken, and A is the acceleration for this section over there. And in the last, I will say there is third equation of motion of motion is available over there. That is 2as is equal to v square minus u square. According to variable stock, there is uniform acceleration, there is displacement or distance, there is final velocity and initial velocity to be taken over there. I will also add here about projectile motion, which is also the part of kinematics. Projectile motion over there. In that case, I will say if he is asking to you related to horizontal displacement in projectile motion, which is 2D motion over there, horizontal distance traveled, then you are going with only Vx multiplied T over there. If he is asking about vertical distance over there or displacement over there, then you are going with half GT square over there. These are the two cases. But sometimes in MCQ questions, if he is asking you about the formula of, first of all, I said time of flight, height of projectile, then you will have, and at the last, I will say range of the projectile, range of projectile over there. Then in that case, when I am taking all of these into account, time of flight will be taken t is equal to 2u sine of theta over g. In case of height, you will use formula u square sine square theta over 2g. For range of projectile, you use the formula range is equal to u square sine 2 theta divided by g over there. These are just like a mathematical expressions when we take into account the projectile motion like that. Like this is the starting point according to horizontal distance, and it is launched with some initial velocity over there like u, and making it an angle theta over there. Then they are being resolved according to these sections. Let's move to the dynamics section over there. Dynamics is basically a branch of physics in which we study the motion with discussing its cause, in which I will have to take first of all, the main quantity which I will describe over here is called momentum, which is quantity of motion, which is the product of mass multiplied velocity. This is vector quantity having the unit kilogram meter per second over there. And this momentum can be taken according to law of conservation of momentum, initial and final momentum like that will be being taken in case by using this momentum over there. Then I will have to move towards the resultant force. Resultant force over there. Then according to resultant force, as we know, the Newton's second law of formula, like summation F is equal to mass into acceleration. That is called Newton's second law also. And we can also take the rate of change of momentum can also be being taken as summation F is equal to rate of change of momentum over there can be taken into account over there. After that, I will say here that as the variables, this is mass, this is acceleration, this is resultant force, change in momentum can also be written as mv minus mu over t as the change of momentum. If I multiply this time with the force, then that is named as impulse, can be having unit Newton second over there. After that, I will have to move towards gravitational field strength, where I can say gravitational field strength. Field strength over there. In that case, I will say that gravitational field strength is weight per unit mass. We means I can say G is equal to W over M, that is gravitational acceleration or gravitational field strength can be taken into account over there. And if I take weight, what is weight over there? Weight is basically gravitational pull of gravitational pull on an object exerted by Earth over there.